Hey everyone, just wanted to share a quick demo of an agentic app built using the Akka SDK. The idea here is to create a temperature monitoring system that helps users understand what's happening with the temperature in certain locations. But instead of simply displaying raw numbers, the goal is to make the information more accessible by presenting insights in a text format that anyone can read. To achieve that, we're leveraging LLMs along with the new agent component from the Akka ecosystem. Let's start with the system design. Imagine a stream of temperature measurements. Each second, a new measurement is emitted in JSON format, like the one on the slide. In our demo, this is simulated via an Akka stream that randomly generates data. But in a real-world scenario, this data would come from something like a Kafka topic or Google Pub subtopic. Regardless of the source, the key idea is the same: processing continuous stream of temperature data. The streaming nature will be exactly the same, just with a different ingestion part of it. Next, all incoming measurements are processed with a key value entity. This helps us group data by location and time window. We've configured a 1-minute window to see the results rather quickly, so each unique combination of minute and location corresponds to a separate entity. Yes, there are many ways to handle time series data, but for the sake of this presentation, let's focus on the agentic integration patterns. From the CQRS perspective, entities represent our write model. They handle commands and store incoming data. The command here is used to record a new measurement. Since the goal of this application is not only to store data, but also to present it in a nice form, we need another component, which is a view. A view job is basically listening for entity changes and transforming the write side into a query-friendly form, a classic CQRS approach. The view implementation is basically 60 lines of code, and the essence is here. We are consuming from the key value entity and transforming the write model into the read model. Later, we would like to query that read model with a SQL-like approach. And that's it. That's all you need to have a fully asynchronous, non-blocking CQRS implementation in Akka. The write part, our entity, is also very straightforward. Basically, we have just one command handler that records a new temperature measurement, that's all. If you are not familiar with the CQRS pattern, in my opinion, it's a very healthy approach. On the right side, I can focus on the recording aspects, grouping logic, and some statistical calculations, if needed. And on the view side, I can flatten the model, adjust it to be more friendly for different types of queries. Potentially, I can create many views with many different queries and read models. Also, Akka views have a great feature. They can stream updates, and we can expose this live stream, for instance, as an HTTP server-sent events, ideal for real-time dashboards. The HTTP endpoint component is very simple. It's like any controller or endpoint that you have already seen. It takes the stream of windowed updates from the view component and exposes it as server-sent events under an endpoint with a given path. That's the basic flow. Data is streaming in and streaming out of the system. Now, just displaying raw aggregates isn't that exciting. So let's bring in some intelligence. We will use an LLM to generate a text summary of temperature trends across all locations based on the last 3 time windows. To achieve this, we have to introduce 2 new components: a timed action that will trigger an agent execution every 30 seconds, and the agent component itself, the star of the show. It abstracts LLM interaction through a consistent and powerful effect API, which I will show you in a minute. From a high-level perspective, this component will fetch some temperature data from the view, feed the LLM with that data so that we can ask for a current temperature situation summary, currently in a text form, but I can imagine that this could be a voice or video message. Agent components don't live in a vacuum. We can get some additional data from other components, but we can also store data and expose them also with the endpoint component. My point here is that the agent component fits very well to the streaming nature of the Akka ecosystem, and it's composable with other components. You have a lot of freedom and flexibility in how to connect all the dots and make really powerful solutions. Now, let's take a look at the agent implementation. Like any other Akka component, it requires a very basic setup. All components should have a unique ID, which is set with the component ID annotation. Next, we have a basic description of an agent. It's useful to document what is the agent's role and purpose. Later, we can feed that information directly into the LLM call, and LLM can decide which agent we should use to achieve a given goal. Such an interaction is not covered in this demo, but it's something worth mentioning. Now we have to extend the agent class, and the implementation itself starts usually with a system message where we can define the agent persona and the main job of that agent, which is an AI system for temperature monitoring. And we are expecting to get some insight about the latest measurements. That's the main part of the prompt. The actual execution is defined in a public summarized method that returns an agent effect type, where we calculate the latest finished time window timestamp. Then gather the last 3 measurements starting from that window timestamp. Transform into a JSON array, and that is our user message. So the system message combined with the user message is our final LLM prompt. The effect API will guide us on how to invoke the LLM. We can, for instance, configure whether we need to enable memory for that agent or what the model provider is. In our case, it's OpenAI provider, but Akka supports many different providers. Actually, memory is enabled by default, and it is also included in the prompt, but in our case, it makes no sense to pass all previous summaries to the LLM. Hence, we can configure the memory to be write-only and just store data without including it for every call. Okay, I think it's finally time to run it and see the application from the user perspective. The application started successfully. Okay, I will just open the browser and visit localhost on port 9000. That's our main table view on aggregated temperature measurements. At startup, we populate it with some historical data. As you can see, every second, more or less, we see an update highlighted with a yellow color. Soon, we should also observe a text summary update on top. The agent call interval is 30 seconds, but the first response should be a bit faster. Let's wait a few more seconds. There you go. It's a raw response from the LLM. Probably it deserves better styling, but it's a detail. What would be even more interesting, from my point of view, is to combine the request to the LLM with tools, able to perform some statistical calculations based on our data. As you are probably aware, LLMs are not that good with math, so we can extend the agent implementation with tool calls very easily. Please look for other Akka demos and samples. That's all from my side. Thanks for your attention. I hope you like it. If you have any questions, I would be happy to answer them. If you'd like to see the full source code, just visit github.com/akkasamples/temperature monitoring agent. See you.